Hello everyone, I welcome you all in the C programming and data structures lecture. This is part 4 of reversing a stack using two temporary stacks. So without any further delay, let's get started. We are done with adding 1, 2 and 3 onto original stack, isn't that so? In the previous presentation, we have learned how to push all these elements onto the original stack. You can see this, that the topmost element of this stack is 3 and the bottommost element is 1. This is the current state of the original stack. Now we want to pop the topmost element of the original stack, that is we want to pop 3 out of the original stack and we want to push this onto the temporary stack 1. This is what we want, and we will learn in this presentation how to pop the topmost element of the original stack and how to push that element onto the temporary stack 1. Okay. Here you can see that top pointer must point to the topmost element of the original stack and top 1 pointer must point to the topmost element of the temporary stack 1. This is very important that we must remember this always. Okay. Top pointer always points to the topmost element of the original stack and top 1 pointer points to the topmost element of the temporary stack 1. Although you also know that there is one more pointer called top 2 which must point to the topmost element of the temporary stack 2. But in this presentation, we will focus on these two stacks because we want to pop an element from this stack and we want to push this onto this temporary stack 1. That is why in this presentation, we will focus on these two stacks and we won't consider this stack for a while. Here in this main function, you can see 3 pointers are declared. We are already aware about this main function. Here you can see I'm calling the series of push functions for the purpose of pushing all these elements onto the original stack, right? And then I'm calling the print function for printing all these elements of the stack, right? This is what we have seen in the previous presentation. Now we must focus on this top 1 pointer because this time we want to push the topmost element of the original stack onto the temporary stack 1. That's why our focus must be on top 1 pointer, right? And you can see it is initialized to null. Now we have to call the pop function for the purpose of deleting the topmost element of the original stack. That means we have to delete this element, and we know that our traditional pop function works in this way that it deletes the topmost element and it returns the topmost element back to the caller, right? So this pop function will not only delete this element but will also return this element back to the caller. And definitely there must be some variable over here which will receive that value. That's why I have declared this data variable over here, and you can see that I have put this line of code data equal to pop, which means that after calling this pop function we will receive this value and this value we will store inside this data variable, right? And this is how our pop function looks like, right? But please remember there is a problem in this pop function. This pop function works only if we have a top pointer declared globally. This pop function is not receiving top locally. It will only receive the global top pointer. But we know that we have to pass our top 1 and top 2 pointers locally to this function in order to delete the topmost element of these stacks, right? That is why we have to update our pop function, right? We have to pop an element from the original stack and we want to push that element onto the temporary stack 1. This is our requirement, right? Therefore, it is important that we must pass the top pointer to this pop function so that we can pop an element from the original stack, right? And here of course we need a top pointer, that is struct node star top, which is local to this function, right? You can see this, that this top pointer is local to this function. Now we can see that our pop function is updated. After returning the value, we will receive this value over here in this data variable, and definitely we will receive this value, that is 3. Topmost element is deleted but the top pointer is not updated in the main function, isn't that so? We have to update this top pointer also. Now we know the exact problem. This is the same problem which we were facing in the push function, right? It is important to return the top pointer from this function, right? But there is one problem. The problem is that the pop function is already returning the value of the first node, right? This pop function is already returning the value of the first node. Now we also want the address of the second node. After deleting the topmost element or after deleting the first node, We want the address of the second node, right? And actually we want to update this top pointer by the address of the second node. That is why it is important to return that address from this pop function. Now we have to return multiple data from the function. We want to return the value of the first node, and we also want the address of the second node. But this is not possible. We cannot write something like this, return val comma top. No, this is not allowed, right? We cannot return multiple values from the pop function. But there is a trick. After deleting this node, we should return the address of the second node. We have to return the address of the second node and the value of the first node, right? We cannot return more than one values from a function, but there is a trick which can help us in returning more than one values. Now what is that trick? The trick is simple. Return a structure instead. We can think of a structure as a user defined type which consists of multiple types, right? We want to return the address as well as the value. Therefore, we can return a structure from the function. We need the address of the second node, that is this address, and the value of the first node. Why can't we return the first node to the caller? You can see this over here that we have the value of the first node in this node and we have the address of the second node in this node as well. Therefore, we can return this whole node back to the caller from the pop function. It is possible, right? So here first we must replace this int data by struct node star temp, and here we must write temp instead of data. And obviously this int must be replaced by struct node star, and here we must delete this val because there is no requirement of this val at all. After this there is no need of this line of code as well, and there is no requirement of even deleting the first node. We will simply update our top pointer so that it can point to the second node of the list. That's it. Initially we will put top inside temp, which means we will store the address of the first node inside temp. And then after this we will simply update our top pointer so that it can point to the second node of the list, right? And here instead of returning val, we will return temp, which means we are returning the whole node back to the caller. This is the state of the stack before deletion. Top pointer is currently pointing to this node. But later, after calling the pop function, the state of the stack changes. You can see this, that currently top pointer is pointing to this node and temp pointer is pointing to this node. And with the help of this temp pointer, we are simply returning the address of the first node, that is this address, back to the caller, right? Here this temp pointer will receive this address. After this we have to update our top pointer. Now we must assign temp link to top. What is temp link? Temp link is 2000. Therefore top is now updated by the address 2000. Now we can easily call the push function to push this element onto the temporary stack 1. That is what we are doing here. And definitely we must receive the address of the first node of the temporary stack 1, and this address must be saved inside top 1 pointer. Is that clear? I hope the idea is totally clear to you. Now let's see the complete code in code blocks. Here is the complete code. You can see we have is empty function, struct node star pop. We have this pop function, right? This updated pop function. Here we are not deleting the first node of the list. Please remember this. We are not deleting the first node of the linked list. We are simply returning the first node back to the caller, right? In this main function, you can see I'm calling pop 2 times, right? You can see this, I'm calling pop 2 times because I want to delete these 2 elements, okay? Let me just remove this. And let's just try to delete these 2 elements, okay? 3 and 2 from the original stack. We will not only delete these 2 elements, we will push them onto the temporary stack 1. And here you can see this, that I have repeated this piece of code twice, right? Because I want to delete these 2 elements from the original stack and I want to push these elements onto the temporary stack 1, right? And here I'm calling print function twice. To this print function I'm passing top, and to this print function I'm passing top 1. Now let's execute this code. You can see the elements of the original stack. There is only one element in the original stack. And now you can see the elements of the temporary stack. You can see that 2 is the topmost element of this temporary stack. Let's try to delete one more element. And now we will remove this print top. Otherwise it will produce the stack underflow message, because now the top is null, right? Let's execute this code. You can see the stack elements are 1, 2, 3. These are all the elements of the temporary stack 1. So our code is working fine. There is no problem in this code, right? But you can see this, our code is less readable and quite messy. We are doing a lot of things in our code, right? That's why our code is less readable and quite messy as well. We will see a better code in the next lecture. Okay.